सबसे पहले the first thing that we'll have to see in kinematics is the displacement time graph. What is a displacement time graph? When we have displacement which is represented by s on the vertical axis and time which is on the horizontal axis, that is called a displacement time graph. Now what does it tell us? The graph itself tells us the variation of displacement with time, negative, जो भी हो रही है, how the displacement is varying. And what is the gradient? The gradient is velocity. How? We say, what is the definition of velocity? Velocity is rate of change of displacement. And in calculus, how do we write rate of change? If s is displacement, the rate of change can be written as ds upon dt, which is rate of change of displacement. And this is another quantity which is called velocity. So gradient of a displacement time graph tells us velocity. Isi tarah, we have a velocity time graph. On the y-axis, we have velocity. On the x-axis, we have the time. First of all, the graph itself tells us the variation of velocity with time. Kitne time pe kitni velocity and so on and so forth. Kis velocity pe kya time hai? The variation itself. The gradient tells us the acceleration. How? What is rate of change of velocity? Acceleration. So this rate of change, yes, this rate of change has another name which is called acceleration. And the area under the graph tells us the displacement or the distance traveled. Agar main, if I differentiate displacement, what do I get? Displacement with respect to time, I get velocity. If I integrate velocity with respect to time, इसी तरह if I differentiate velocity with respect to time, if I differentiate velocity with respect to time, acceleration. So if I'll integrate acceleration with respect to time, I will get velocity. इसको लिख लो जल्दी से. Okay, for a uniformly accelerating object, if I draw a velocity time graph, this is how it will always be a straight line, a velocity time graph for a uniformly accelerating. The initial velocity is called u, the final velocity is called v, acceleration is called a, and the time that it takes, call that t. Okay, first and foremost, how do I find the average velocity for a uniformly accelerating object? How do I find the average velocity? How do I find the average velocity for a uniformly accelerating object? Average velocity can be found by two ways. Ek to u plus v plus u upon 2, and the total distance traveled, which is area under the graph, divided by time. Likh lo zara isko. This is how we can find average velocity. Remember, this is very specific for a uniformly accelerating object. V is the final velocity of any particular motion. Motion वही होगा जिसमें acceleration same है. The moment acceleration changes, the motion changes. And this is only valid for a uniformly accelerating object. Is this clear? So there are two ways of finding the average velocity, which is v plus u upon 2. कब? Uniformly accelerating objects, and nowhere else. कहीं और मत लगा देना. And average velocity can also be found by taking the total displacement divided by time taken. Because both of these are average velocities, can I equate both?
Area of graph is actually
Displacement. So v plus u upon 2 is equals to s upon t. Cross multiply karke we can make this equation. These equations that we'll be doing are called SUVAT equations. SUVAT. Because these are the 5 variables that will be in focus: displacement, initial velocity, final velocity, acceleration, and time.
Can you take P for one?
We will do everything, don't worry. Sab karenge isko. We will vary it every way. What variable is absent from this equation?
Acceleration.
Yes, so this is an equation without acceleration. Acceleration is v minus u upon t, which is the gradient of the graph, right? इसको change करते हैं v is equals to u plus at. Which variable is missing from this equation?
P.
नहीं है तो
S.
s is missing from this one. So we have two equations, one without a and one without
S.
s. Now can I substitute this v in place of this equation? v की जगह can I plug in u plus at? Do it. इस v की जगह u plus at डालो. Plug in u plus at in place of this v. क्या आएगा? 2s is equals to 2ut plus at square.
Plus 80 square
Plus ut plus ut is 2ut. And then you can just divide this 2 on the other side. If you divide this 2 on the other side, you get ut plus half at square. Is that right? Now this equation is without v. So we have an equation without s, then we have an equation without v
A.
and without a. अब दो रह गई, without u and without.
Without T.
Very good. So without u कैसे करेंगे? Again, if I make u the subject of the formula from this one, so u is v minus at. U is
V minus A T.
yes. इसी जगह पे in place of this you can plug in v minus at. करो plug in original equation में v minus at. In place of this you can plug in v minus at. I know in physics you specifically used two particular equations. In mechanics हम will be using तीन use करते थे maximum. In mechanics ये चार हम ज़्यादा use करेंगे. ये पहली वाली जो है it's very rarely used but it can be.
Equals to VT plus VT minus 80 square.
Yes, so 2vt minus 80 square. Now divide by 2, so s becomes equals to vt minus half 80 square. This is without u. Is that right? Now you can take t common in this if you want to.
Divided.
And यहाँ से t को subject बनाओ, v minus u upon a. So t is v minus u upon a. You can plug it in this equation. T को common लो, t की जगह v minus u upon a plug in करो. Simplify and tell me the equation that you end up with. And this will be the equation without t. V plus u, v minus u is v square minus u square. And now this equation is without t. So these are the equations. So what equations? इसमें से ज़्यादातर this is a very simple one. We can easily use this. उसके अलावा this is the one that you also use in physics. And similarly this one you rarely use in physics. And इसी तरीके से we have this one without t.